Hello everyone and welcome back to my channel XYZ Architect. The first thing you have to know before you start to create a measuring program or to measure products is how do you measure them. Today we are going to find out, and we can start this new video with the information from the cookbook from Zeiss company that says the following. Functional check. The part is being checked against the designed functional requirements. This check is for assembly purposes, prototyping, gauge replacement, incoming and outgoing inspection. The result will cover fitting, matting situations, functional datums, and so on, in order to accurately report the deviations of the workpiece. Process control will be run if the part under consideration is still within the manufacturing loop. That is to say that the part is still in the process of being made. This enables the operator to control production parameters, process flow, or calculate CG, CGK or gauge R&R values. A typical use of a process check may be to show possible manufacturing deviations such as worn tools, clamping errors, location errors. These results report information about the relative deviation of the workpiece during serial production. So in other words, if you want to check the functionality of the part, you check by the functional check, and if you want to control the process, you will do a process control check. You can find more about these details in the cookbook from the Zeiss company. You have a link in the description below and you can buy the book from there. So, how do we do this, all this that the cookbook says? Stay tuned and find out next. Which way are you going today? Functional check route or process control? I'm going to start by showing you an example from the functional check. Okay, make an application with Calypso, then I will show you a process control example and continue with the application from Calypso. How does that sound? Okay, let's go. So let's say that a claim from a client comes to your company and quality departments assumes that the root cause is the diameter from the location E7 from the drawing. What do? Well, there is some steps that it's recommended to follow in order for you to complete this task. And these steps are: make sure the part with the defect is available for inspection. If not, then you should ask for a part from the actual production to see if the defect is also in the actual production. Make sure you have the latest version of the drawing and the latest version of the CAD model if there is available a CAD model. Inspect the drawing and identify the datums and the dimensions you need to measure. Choose the correct methods of measurement and evaluation. Verify if there is a dedicated fixture. If there is none, then construct one that blocks all degrees of freedom from the part without deforming it. Choose the correct styli for the measurement program and make sure they are qualified, and start making the measuring program. Okay, so in our case, this is our drawing, okay, for the part. Okay, so as you see here, I've identified the datums from the drawing. There is only one datum. That means that I can do wherever I want with the alignment as long as the primary datum is A. And I've identified the dimension that needs to be measured. Okay, so E7, right? E7, this is the dimension that needs to be measured. The diameter of 40 millimeters plus minus 0.02. Now, since there are functional dimensions in the drawing, as we can see here, this is a shaft. This is considered a shaft. And in order to correctly measure a functional diameter of the shaft, we will have to evaluate the diameter with a minimum circumscribed cylinder. And of course, if we want to measure the whole of the counterpart, we will have to evaluate the diameter as a maximum inscribed cylinder. As you see here, these dimensions has an asterisk right here, and if you go in the right side of the drawing, you can see that dimensions marked with the asterisk are functional dimensions. Dimensions marked with this symbol between them inside, and inside there is a dimension, are used for process control. So usually the drawings are designed like this. You should look for this text in the right side or in the legend of the drawing to identify correctly the functional dimensions or the process control dimensions and everything else. Okay, let's go back to our example. Okay, so we have inspected the drawing and we have correctly extracted the datums and the dimensions that need to be measured, right? Okay. Now, the information is pretty much clear. The problem is that this part doesn't go inside this part like this, like we can see here. Okay, and that's why they want to measure this part. But we can see that in order to do a correct measurement and a correct evaluation, we have to also measure the counterpart, right? So we have identified now an additional information, right? And we have to inform quality about the additional information that we identified. And if they agree with this information, then we go and measure the additional the counterpart with the additional information, or we just measure what they want. But usually they take in consideration what we as CMM programmers, as engineers tell them, because usually we know what we say. Most of the time we know what we say. Okay, so now we have to measure this diameter for this part and this diameter, the inside diameter, for the counterpart. Okay, so let's say also that we have selected the correct styli configuration and we made sure that they are qualified, and now we can go further and make the Calypso application. Okay, so after we checked our drawing, after we checked our stylus system and choose what stylus system we want to use, and after everything is clear, we have to go and create the measurement program. So here is the drawing from the part presented before. This is the part, and as you remembered, this is the functional dimension that we want to check. Okay, so we can see that it's also, the drawing is also asking for a perpendicularity from datum A to this one. Okay, so we will check that also, because remember geometrical elements, geometrical dimensions are always functional, right? So perpendicularity and flatness we are going to check because they are functional dimensions. Okay, so let's go to Calypso. Okay, this is the part I already imported the CAD model. Okay, so I'm going to work very simple. I don't think you will need to see exactly how I'm doing the alignment. I will do it, but it will be in fast forward. So okay, so now that we have our alignment, long story short, I've created plane as a datum A like we saw in the drawing. I created the cylinder, I created the intersection between the cylinder and datum A for the origin, and this is a help circle to help us find datum A all the time. So I'm going to change here the X. I'm going to put a formula on the X. Take the X from the circle, the help circle, and the Y again from the help circle. Okay. Okay. Yep. This is it. Okay. And now that we have this, let's go to cookbook to see exactly what do we need to measure, right? And how do we need to measure. Okay, so this is a reading sample from the cookbook. It's online, it's free, but I do recommend you go and buy the whole book if you want to have every information that you will need for every element. As you see here, there are a lot of measuring strategies for a lot of elements. So as we saw earlier, we have let us see, shaft, right? So we have to check the diameter for functional check at page 57. Let's see if we have that. I think we have that, yeah, but if we do not, then oh yeah, we have this. Okay. Okay, so let's see. So we do know from the drawing that we have a height of the cylinder is 35.26, okay, and the diameter is 40. So the diameter is bigger than the height of the cylinder. In this case, the cookbook says if the height is smaller than the diameter, then you should only use one circle, right? So one circle is enough, even if you are measuring a functional dimension. So we will use one circle at any cross section, and we do have 3 of them because we made 3 sections for the cylinder to make the intersection. So we can recall any of that circles to check the diameter. Again, we should see if the diameter is bigger or is between 26 millimeters to 80 millimeters, then we should use for a passive sensor a speed of 3 millimeters per second and 1270 points minimum and 380 degrees on the radius, and the max stylus of 3 millimeters. So let's see the strategy. We have to change here. Okay, 3 millimeters per second. Okay, 380, and okay, this is good. Okay, so let's also recall one of the circles. So let's recall one of the circles from the cylinders. Right click, open, and choose which one do you want. 1, 2, or 3. Okay, I'm going to choose the first one because usually this is the first one that comes in. But the problem is down here. So this part goes inside this part, and I'm going to choose this one. Okay. Okay, so the diameter is fine. The nominals for the X, Y, and Z are correct. Okay. Let's name this circle position 1, for example. Okay. Then this is cylinder position 2 because we are going to use this for the perpendicularity. We have all the features we need in order to evaluate all the functional dimensions from the drawing. So first of all, let's check the diameter. Just check the D from here. Okay, as I recall, there is 0.2 tolerance. Okay, so 0.2 minus 0.2. Let's call this position 1. Okay, then we have to check also the perpendicularity. And we choose the cylinder for the perpendicularity. Okay, also 0.2. This is position 2. Okay. This is according to datum A. Okay. And then we have to also choose the flatness of datum A. Okay, and for this we have 0.05, and this we will call 1, 2, 3, 4. Okay, so this is position 4. Okay, good. Let's check also if for the datum. Okay, so the strategy should be like this. Okay, now it's fine. Remember, when you scan the part, you should always use filter and outlayer. Just leave it like this by default and it should be fine. Also for this one, okay, and I think this is it. We have what we need in order to give to the quality. Okay, but we notice that we have also this part, and we want to check to see if this part is okay also, because this part comes inside this part. And also we want to check the circle. Okay, minimum circumscribed element. Okay, now it should be fine. For this one you shouldn't bother because it's already as a minimum circumscribed element, and for this one is already as a LSQ feature. Okay, and of course when you do a flatness it will be a minimum feature evaluated for the datum. Good. Now let's generate a report. Forgot to set the clearance plane. Okay, so here we have the dimensions, the diameter, the perpendicularity, and the flatness. So let's see also details. Okay, so this is the flatness. You know, if you want to see it at a plot protocol as a bigger picture, you just have to click it. And you have it like this. Okay, so we do know now that we also have the part from here, right? So we have also this part to measure, so we can go and talk to the production and say to remove this part and let only this part here. So we can go to cat file, modify entities, and select this one and hide it. And now we only have this one. Okay, and we go and make a alignment for this one, but just for this example I'm just going to measure a circle right here. So let's see this, let's say this is an extra position. Okay, let's say the strategy again is 13,000 3 millimeters per second and 380 degrees. Okay, just execute it. Okay, and let's see if yep, or we can say that this should be 0.05 and minus 0.05, and okay, and now we see the problem, right? So the problem was not the part from the upper side. Okay, so was not this one, the problem was this one. So this part is with the problem. Okay, so now that we know, but this is measured in least square, right? So this is least square. Now let's see if we set here the correct maximum inscribed element for a hole, right? So we use maximum inscribed element, apply, okay, Let's see now. Okay, so now it's fine. Okay. So as you see, this part is also okay, and they should fit one inside another. Okay, good. Now we can go and see also how the process control is being measured. And for this I choose the counterpart of the previous part that we talked about. So the asking for from the quality is to measure dimensions marked on the drawing with process control specifications, 3 parts for every shift. So every shift we have to receive 3 parts from the production, and we have to measure them. The steps are almost the same, but there are slightly little differences. So again, make sure you have the last version of the drawing and the latest CAD model. Inspect the drawing and identify the datums and the dimensions you need to measure. Choose the correct methods of measurement and evaluation. Verify if there is a dedicated fixture. If not, construct one that can block all degrees of freedom from the part without deforming it. And I do recommend for process control there should always be a dedicated fixture checked and reviewed by the design department. This is an important measurement, and you have to have repeatability and reproducibility on it. You have to make measurement system analysis on it. There will be this kind of request from the client, and you will have to give them this. And if you don't have a dedicated fixture, then you will most certainly have a problem with this. So make sure you have a dedicated fixture. It's the best way to keep things in control. So choose the correct styli for the measurement program and make sure they are qualified. Now you have to make sure the styli are qualified each time you do the measurement for the parts. And also another thing that you may probably still have to keep in mind is that the parts need to stay in the measuring laboratory, in the measuring room, depending on the material that the part is made. You have to keep the parts in the laboratory from 2 hours to 48 hours, and then you can start to make the measurement program. Okay, so we go back on our drawing and we can see that we have a dimension marked for process control is the diameter from here. So for process control you just have to make sure that the dimension is repeatable and it's correct measured. So from my point of view, on this kind of diameter you just have to take 7 points on the diameter at any cross section you want, and the evaluation should be a least square, so a Gauss. Okay, coming back again, we've identified the datum, we've identified the dimension needed to be evaluated, and of course this is a 3D representation of the part. Okay, so information is clear. We checked the styli configuration and picked the styli, the correct styli, and we fixed the part, and we can go and start create the program. Now we can go back to Calypso and we can use exactly the same part because we have access to the exterior diameter from the counterpart. In order to make the process control diameter, so we do have a specification of this diameter for process control, right? So for this part, okay, so we are going to use the same program. We are going to take this helped diameter because it's enough. Okay, so according to cookbook, we have here the process control shaft to the position or diameter, right? So it's one circle. So we have here the diameter. We just check the diameter. We insert the tolerance. The tolerance is 0.1. So we set here 0.1 minus 0.1, and this is position 3. And we also have this one, position 3. This is out of specification for this part, so it's not okay. So we do have in the end not okay part. It's also a least square because this is the way we have to measure a process control dimension, and it's out of specification. Good. So this is it for this example. Okay guys, thank you for watching. Thank you for appreciating my work. I hope you enjoy what I'm doing. I hope you enjoy that I'm trying to give away my knowledge somehow. Please leave a like if you enjoy my content, subscribe if you're not a subscriber yet, and of course, until next time, have a nice one.